Welcome to today's Explainer. We're unpacking a literal real-time ecological detective story unfolding right now in the Northwestern Atlantic. For decades, scientists knew this specific, highly successful marine traveler was bound to arrive in these historic waters. Well, it's finally here, and it's bringing with it a massive wave of biological uncertainty, economic paradoxes, and, honestly, total ecosystem rewiring.
Okay, let's dive into this. It all started back in the summer of 2025 with something as simple as a text message. UMass Amherst researcher Allie Putnam got a photo from an observant University of Rhode Island student named L. Fernicke's hartshorn. The photo showed a clam that just didn't look right. It didn't match any of the native New England bivalves. And this single, seemingly tiny citizen science observation, it sparked a massive, multi-institution investigation.
Part 1. A suspicious discovery. Unraveling the marine mystery.
Now, to really grasp why this was such a huge deal, you've got to remember that the Northwestern Atlantic was essentially the last major northern hemisphere region without this invader. And man, just look at how fast this moved. Right around the time that students sent the text message, veteran shellfishermen on Cape Cod started finding these weird clams in their rakes. Shortly after that, marine bioinvasions expert James Carlton connected the dots between these scattered reports. Then, just months later, fieldwork provided the absolute smoking gun. We're not talking about empty shells tossed from a seafood market. They found undeniable proof of an established, self-sustaining population, dozens of live juveniles right in Boston Harbor, and actively reproducing adults down on Cape Cod.
Part 2. The $7 billion invader, a complex paradox. So, who exactly is this invader? Meet Ruditapes philippinarum, better known as the Manila clam. Originally native to the coastal waters of Japan, Russia, and southern China, this bivalve is an absolute powerhouse of survival. It's incredibly resilient, boasting a massive tolerance for wildly varying salinities and temperatures. When you combine that adaptability with a remarkably rapid growth rate and a super high reproductive output, you get a biological profile custom-built to be a formidable invasive competitor.
Now, what's really interesting about this slide is the sheer scale of that number. $7 billion. That is the approximate global value of the Manila clam industry. You see, this isn't just some unwanted pest, it's an aquaculture darling. Because of its culinary appeal and fast growth, it's been spread around the world both intentionally and accidentally for over a century, becoming literally one of the most commercially significant bivalves on Earth. Which leads us to the ultimate question for coastal managers in Massachusetts right now. Is the Manila clam an ecological disaster, or is it a highly lucrative commercial opportunity? I mean, in places like Europe and the Pacific coast, it's fully transitioned from an invader to a major fishery. But trying to integrate a non-native, rapidly multiplying species into New England's tightly regulated shellfish framework, that is an incredibly complex management dilemma.
Part 3. Breaching the thermal barrier. Climate change as an accelerant.
Historically, the cold waters of the Gulf of Maine acted almost like a natural, impenetrable fortress wall. It literally kept warm-tempered species from moving northward past Cape Cod. But that environmental defense system is broken. The Gulf of Maine is currently warming faster than almost any other body of water on the planet. And as those temperatures rise, what used to be a thermal barrier has essentially turned into a thermal green light, making the habitat incredibly hospitable for invaders like the Manila clam. Let's move to and see how this builds, because when we look at the larval biology, the threat really multiplies. These clams start out as microscopic larvae just drifting in the water column, hitching rides on coastal currents and tides across vast distances. We're talking sometimes dozens of miles from a single spawning event. Eventually, they settle on the seafloor and rapidly reproduce. This current-driven, pelagic phase makes containing the Manila clam exceptionally difficult. I mean, you could eradicate them in one cove, and the neighboring town's clams will just resupply your water with fresh larvae. So how do they even get into the water in the first place? Well, scientists are looking at 3 main invasion vectors. First up, ballast water from international shipping, entering major ports like Boston Harbor. Second, the global live seafood trade. Since these clams are sold alive in local markets, a well-meaning release or just improper shell disposal could have easily kicked this all off. And third, recreational boating and trailers. To really pinpoint the exact origin, scientists are going to need to rely on some heavy-duty DNA sequencing.
Part 4. Rewiring the coastal ecosystem, threats, and unexpected shifts. And this brilliantly illustrates the real conflict here. Finding out where they came from is one thing, but dealing with the ecological aftermath is a whole other beast, especially since this clam acts as an ecosystem engineer.
On one side, you have the native softshell clam and the northern quahog. These are ecological keystones, deeply, deeply rooted in New England's traditional shellfishing heritage. On the other side, the invasive Manila clam. Because it occupies the exact same shallow habitats, it aggressively competes for space, monopolizes food resources like phytoplankton, and actually physically alters the sediment dynamics.
But here's the catch. The net impact of an ecosystem engineer is highly unpredictable. For example, thousands of filtering Manila clams can actually clarify local waters, allowing more sunlight to reach the seafloor, which encourages the growth of aquatic vegetation like eelgrass. Sounds great, right? But simultaneously, that intense filtration can deprive native filter feeders of essential food particles, effectively starting them out. So one positive effect can easily trigger a negative cascade somewhere else.
We also have to look at the other side of the ecological coin here. Carolina Bastidas from MIT Sea Grant points out that this new abundance of clams could serve as a food source for local predators, like green crabs and seabirds. Now, if predators actually prefer the thin-shelled Manila clam, it might relieve predatory pressure on the native soft-shelled clams, helping them survive. Or it could just cause predator populations to boom entirely. It's a completely unpredictable shift in the whole predator-prey dynamic.
So what do we actually do about it? Managers are essentially staring down two paths. Path A is eradication, which is notoriously difficult and, let's be real, often impossible once a marine invertebrate is established. Path B is commercial exploitation, which could be super lucrative but totally threatens native shellfishing traditions. And making matters even worse, shellfish management in Massachusetts is fragmented town by town. One town protecting the clam for harvest while its neighbor tries to eradicate it. That simply won't work with a current-driven invader. State-level standardization is going to be absolutely essential here.
Part 5. The New Coastal Reality, a highly dynamic mixture.
What we are witnessing right now is the dawn of a new coastal reality. The historic cold water fisheries of the Northwestern Atlantic are shifting into a highly dynamic, totally unpredictable mixture of local and introduced species. The successful colonization by the Manila clam is a stark reminder of our porous borders. Human connectivity through shipping, live seafood trades, global travel has woven isolated ecosystems into a single globalized web, basically breaking down evolutionary boundaries that stood for millions of years. And this underscores a very real, urgent need for stricter biosecurity protocols and serious investments in early detection technologies, like environmental DNA monitoring, so we can catch these invaders before they take over.
As these seas rapidly warm, we are left staring down massive uncertainty regarding the native species that truly define New England's coastal identity. We are standing at a crossroads, trying to figure out if we're facing total displacement or the emergence of a brand new, turbulent hybrid ecosystem where natives and invaders somehow strike a delicate balance.
As UMass Amherst researcher Ali Putnam summarizes, finding the species is only the beginning. This research will help us determine whether this newcomer becomes a minor addition or a more influential player. Thank you so much for joining me for this explainer today, but I want to leave you with one final thought to consider. Will the Manila clam completely wipe out native New England species, or is this just the first turbulent step in a completely rewired coastal future? Keep your eyes on the coastline, everybody. This story is just getting started.